In this video, I'm going to talk about semiconducting materials or electronic components. So before going to the semiconducting material, I want to talk about types of materials. When it comes to the electrical point of view, we have three types of materials. One is conductors, another one is insulators, and the third one is semiconductors. All these electronic circuits completely depends upon the semiconducting material. So what are conductors? How do you define which one is conductor, which one is insulator, which one is semiconductor? Conductor is it always allow current. So conductors are it allows flow of electrons. The best example for conductors are all metals as well as carbon, lead. These are all the conductors. When it comes to the conductors, resistance value goes up as temperature going up. Okay, so important point you need to remember, resistance of a conductor goes up with the rise in temperature. Insulators, on the other hand, they do not allow any flow of current. For the insulator, resistance value goes down as the temperature increases. Okay, at one point these insulators are going to start conducting as the temperature changes. On the other hand, semiconductors, they allow sometimes current, they do not allow sometimes current. So what is the condition between these two? When it is going to allow, when it's not going to allow, I'll talk about it in a minute. So let me talk about conductors. So before going to these three materials, I want to talk about atom. So when you look at an atom is going to have a nucleus. In the nucleus, we have protons, which have positive charge, and neutrons, which doesn't have any charge. But electrons are revolving around this nucleus. Electron we indicate with E minus. Okay, so this is called orbit. So each orbit can hold certain number of electrons. So the first orbit can hold up to 2 electrons, second one can hold up to 8 electrons, and the third one can hold up to 18 electrons. So that number is basically, you can define by 2 to the power of n square. So n is number of orbit number. So here n equal to 1, n equal to 2, n equal to 3, n equal to 4. Okay, so each orbit can hold that many number of electrons. So here if you look at the atom, most probably most of the atoms will end up to 4th orbit. Now these atoms want to be stabilized. These atoms are going to be stable when they have 8 electrons in its outermost orbit. Okay, if it doesn't have 8 electrons, what it will do, it will try to get that 8 electrons, or if it has more, it will try to get rid of. At the same time, even if it has more, 18 electrons, if the orbit is full, even that is also going to be stable. If it is not full, then definitely it wants to have 8 electrons in its outermost orbit. So either full number of electrons or 8 electrons, remember that. Now if you look at sodium, Na, okay, Na atomic number is 11, that means it has 11 electrons. So if you look at Na, it has 11 electrons, so 2 electrons are going to be here and 8 electrons in the second orbit and the remaining 1 electron in the third orbit. As we discussed, it needs 8 electrons in the outermost orbit, so if it can get rid of this 1 electron, this atom is going to be stable. Okay, so every atom wants to be stable, so it will stabilized by getting rid of this electron. At the same time, if you look at chlorine, so chlorine atomic number is 17, so it has 17 electrons. So the first orbit has 2 electrons and the second one is 8 electrons. Okay, and the third one is 17, right? So we have 7 more electrons in the third orbit. So this chlorine needs 1 electrons to be stabilized. So what happens, these two get a bond. That bond is called covalent bond. We're not talking about the bonds here. So it will get a bond and it will give away this Na will give away that one electron, chlorine borrow that one electron, this will become sodium chloride. Now for the conductors, as long as this material, so whenever an atom has this excessive number of electrons which it wants to get rid of, those atoms are going to be act like a conductors. Now when it comes to the insulators, these electrons are completely in bond, there are no free electrons. So basically those materials are going to act like a insulators. Our paper, porcelain, wood, dry wood, plastic, rubber, these are all the insulators. Now the third one is semiconductors. Okay, semiconductors. Before going to the semiconductor, let me talk about this conductors or insulators one more time. So when it comes to the conductors, okay, this is the outer band, right? Okay, so this is the band, I mean orbit basically. So an electron can jump from one band to another band. If it gains energy from, then it will jump out, okay, from here to here, here to here, depending upon how much energy it gained. If it loses energy, then it will go into the inner bonds. So basically the electron which is here in the outer orbit definitely has lots of energy. Now I'm talking about this outer band or orbit, so I'm talking about this. If we look too deep into this band, okay, it is separated into conduction band and valency band. So conduction band is right there, and valency band is up here, or vice versa. Basically this must be valency and this must be conduction. Okay, and there is an energy gap. So all the electrons are in the valency band. So I'm talking about this outer orbit. I'm looking very close into this orbit. So when we look into this orbit, we will see conduction band, valency band, and energy gap. So electrons are always in the valency band. Now I'm talking about this is an insulator. Okay, when it comes to the insulator, now to jump this gap, they need lots of energy. Okay, once the electrons are in the conduction band, so it will act like a conductor. Okay, for the insulators, this energy gap is really high. The energy gap is really high in insulator, so it won't act like a conductor. When it comes to the conductor, that conduction band and valency band. So here is my valency band and here is my conduction band. These two are kind of overlapped. There is no energy gap at all. So electrons can easily move from conduction band to valency band. So that's how these are called conductors, because there is no external energy needed to move the electron from one place to another place here. When it comes to the semiconductor, okay, I will talk about the energy band in a second. So semiconductor is, it allows current in sometimes it does not allow, depending upon the external condition. So if I give a little more heat is nothing but energy. So if I heat this atom, the electron will gain energy, so it will try to get away from that outermost orbit. Okay, at the same time, if we apply pressure depending upon the material, so that's how you transfer the external energy. Once you give external energy, the semiconductor is going to start conducting. When it comes to the semiconductor, there is another way of defining semiconductor. It always has 4 electrons in its outermost orbit. Okay, 4 electrons in its outermost orbit. So semiconducting materials have 4 electrons in its outermost orbit. Okay, so if you look at carbon has the atomic number for carbon is 6. Okay, so basically it has 2 electrons in the first orbit, and the second orbit has 4 electrons, right? But this is the only material acts like a conductor. This is carbon is not a semiconductor, even though it has four electrons in its outermost orbit. Other semiconducting material, more famous semiconducting material which has 4 electrons is silicon and germanium. Okay, silicon atomic number is 14, germanium atomic number is 32. So if you draw an atom, you will end up, okay, so here is an atom, silicon. So the first orbit has 2 electrons, the second one has 8 electrons, okay, the third one has 4 electrons. Okay, that is silicon. Germanium, when it comes to germanium, 32, right? So 2 in the first orbit, 8 in the second orbit, 18 in the third orbit, and then 4 in the fourth orbit. So 2 plus 8, 10 plus 18, 28 plus 4, 32. So silicon and germanium, these are the very famous semiconducting material. You heard about Silicon Valley, right? That Silicon Valley, the name came because most of the industries are there are electronic manufacturing companies. So those electronic manufacturing companies use silicon as their base material. Okay, silicon is the cheapest one. I mean, silicon is nothing but basically the sand what you see outside, but they need to process it to make it a pure silicon, or not pure silicon, to make it as a useful semiconducting material. Okay, so in this video we learned about conductors, semiconductors and insulators. So semiconductors, they allow current sometimes depending upon the external conditions, sometimes they do not allow, and all the semiconducting materials have 4 electrons in its outermost orbit, and silicon, germanium are the more famous semiconducting materials. I will stop this video here. In the next video I will talk about more about n-type material, p-type material, and a p-n junction. Thank you.